Hi, this is Purnima Mahalingam, and you're watching video lecture series on protection switchgears. In this video lecture, today we are going to discuss about overcurrent relay. In last series, we are discussed about what is the relay and operating principle of relay and electromagnetic relay. So today in this video, we are going to discuss about overcurrent relay. Come, let's go discuss. Here comes what is overcurrent relay. Overcurrent relay, its definition is overcurrent relay is defined as the relay which operates only when the value of the current is greater than the preset value setting time. It protects the equipments of the power system from the fault current. So overcurrent relays which are used to protect an electrical system. Example. um, is used to protect an electrical systems equipments from overcurrent fault like thermal current and short circuit current. For different characteristics of circuits, equipments, overcurrent relays are of different types, such as motor takes 3 to 5 times of its rated current at the starting of the time. That is what an overcurrent relay interaction and why empathy about. Now coming to overcurrent relay, here comes the overcurrent relays are classified depending upon the time of the operation. These relays classified as instantaneous overcurrent relay, which is lower than 0.01 seconds, and inverse definite time relay, and inverse definite minimum time relay (IDMT) is a very important, and very inverse relay and extremely inverse relay. Here coming to the based on that different types of relay, how it reacts. Here we can see how it is reacts. This is the multiples of pulsating and operating time seconds. Here we can see operating time seconds. So what happens? It is when operating time seconds is high. What happen? It gets and definite time relay, it takes some definite time. So IDMT relay is the extremely inverse relay and very inverse relay. You can see the various type of graphs, how it react based on the fault, the relay react. Now coming to instantaneous overcurrent relay, we can see here is a restaking a spring, and we have a no contactor here. Here we have a current coil. Once the current coil get energized, what happens? It pull down or pull up, whatever may be. Once the contactor get closes, what happens? It gives signal to the relay circuit breaker, and it will close circuit breaker will close and isolate the main part from the supply part. This is an instantaneous overcurrent relay. It takes less than 0.01 seconds. Okay. Now coming to the definite time relay, here comes to the definite time relay. What happens? It is here is a two condition is needed for definite time relay. Is needed to satisfy the operation, that is tripping. The fault current must exist the set values. So the fault current must exist the setting time. Fault current, that is set value, and the fault must be continue at least a time. At least a particular time, the fault must be continue at the time equal to the time setting of the relay. So this is what an definite time relay. The fault must exist the set preset value, and it must be constantly must be equal to the time setting of the relay. Now coming to inverse definite time relay. So inverse definite time relay characteristics, the natural characteristics of any induction type rotating devices. Here it means the speed of the operation of the rotating arc of the devices is faster if the input current is increases. What happens if the input current is increases? What happen? The speed the speed of the rotating of the arc of the devices is faster if the input current is increases. So here the discrimination by the both the time and current. The relay operated at the time is inversely proportional to the fault current. The relay operation is inversely proportional to fault current. Here we can see the graph. Here it is time, and what about this is the current. What happens here? It is when the time is high. What about the current? When the current is low, what happened? The tripping time will be high. When the fault current is high, the tripping time will be low. Okay, this is what an inverse time over current relay. Now coming to this operating the characteristics of operating relay, which is a time current relationship. Here comes the operating time decrease as current increases. Operating time decreases as the current increases. Here we have the time and the current. Okay, and enable selective coordinations, so prevent unnecessary stripping and improve stability, system stability, reliability. So adjustable time and current setting. Here we have a small example, that is heavier fault, faster relay operations. And fun fact, it is overcurrent relay, which is heat rushes, more current, the faster the act. If the current is more, the faster the act, if the relay acts faster. Here coming to now coming to the summarize. So empathy is whatever fault and exits currents, overheating and damages and system instability. Here, what is an empathy defined? Which the current exists, then a fault occurs, and need for separation of the protection. We need to separate the system, and we have to protect. What is the idea? It is a CTN pickup setting. We have a setting the preset value and tripping signals to breakers and inverse time relay and instantaneous relay. And we have a uh, time current curve and advantages and limitations and needing coordinations. Here coming to the test with the distribution networks, transformer backup, sorry, and motor overloaded. So what is curious questions? It is directional relay, or do you have any speed limit? Okay, so that's all about today video about overcurrent relay in past and protection switch here. I hope you understood this, and we'll meet in the next class. Thank you so much.